In this section, we're going to be looking a little more deeply into the parabolas and what they actually mean in real-life situations. So your goal or your objective for today is I will be able to identify the vertex from all quadratic forms, which you've got standard form, vertex form, and factored form, and we'll describe the minimum and maximum as well as the domain and range. Just a quick review. The vertex can either be the highest point or the lowest point of the parabola. Remember that the vertex is a maximum if the parabola opens down. The vertex is a minimum if the parabola opens up. And just a quick review from our last section, when the parabola opens down, it is a sad parabola. That means the coefficient is a negative number that is on as the a value. For example, we might have y equals negative x squared plus 2x plus 3. That one would open down. A positive a would look something like y equals x squared plus 2x plus 3, where the a, the 1, is positive. Quick review to make sure we know how to find the vertex. When it is in standard form, we use the a, the b, and the c, and we use the formula x is equal to negative b over 2a. Once we have found that x value, we now need to plug the x value back in and solve for y. Once we have the x and the y coordinate, we have the vertex. And if you paid attention and actually listened to the last video, you learned that we have a 1:3:5 ratio once we have found the vertex. If a is 1, we rise 1, run 1 to get the next point. And then we rise 3 and run 1 to get the next point. And then we rise 5 and run 1 to get the next point. And then you can do the same mirror image points to the left. And that is how quick and easy we can graph our parabolas once we have the vertex. So this should all be a quick review, just jotting down some basic notes. So let's take a moment, look here, find the vertex, the domain and range of the parabola from standard form. Remember, we're going to go with x is equal to negative b, whereas b is a negative 4. So we're going to sub in a negative 4 all over 2 times a, which is 1. Well, a negative times a negative is a positive 4. 2 times 1 is 2. 4 divided by 2 is 2. That means the vertex occurs with an x-coordinate of 2. Now I just need to find the y value. Well, y is equal to x squared, so there's my 2 squared, minus 4x, so 4 times 2, plus 9. 2 squared, 2 times 2 is 4. Negative 4 minus 2 is negative 8, plus 9. 4 minus 8 is negative 4, plus 9 is positive 5. So the y-coordinate of the vertex occurs at 5. So the vertex is 2, 5. Now, is this a minimum or a maximum? We'll take a moment and look at A. Was A positive or negative? A is positive 1, so it is a happy parabola. It is opening up. That means the turning point is the lowest point before the graph continues up. So that is a minimum. Domain and range, it is going to always go from negative infinity to positive infinity. Now the range, so let's take a moment and think about the range. If that vertex at 2, 5 is the lowest the graph goes, the y number tells us the up and the down, so the lowest the graph goes is 5. The highest, because it's open facing, it goes up as high as forever. So we can actually get the domain and the range without even seeing the graph, simply by understanding what the vertex is of the parabola. When you have those questions answered, go ahead and move on to the next one. Take a moment and look at this one. Identify your key things. A is actually a negative 1 this time. B is a positive 4. And C is a positive 5. If we want to find the vertex, we're going to go with x is equal to negative b, which is 4, over 2 times a, which is a negative 1. So negative 4 over negative 2 is a positive 2. So the vertex occurs when x is 2. Now we need to find that y coordinate. Well, we have a negative times x squared plus 4 times x plus 5. Now pay attention carefully. In the original equation up here, which I'm pointing out in a circle in red, it is a negative with no parentheses. That's negative 1 times x squared. So we're going to square the x first, which is 4, times this negative 1 is a negative 4. 4 times 2 is 8, plus 5. Negative 4 plus 8 is negative 4, positive 4. 4 plus 5 is 9. So the y-coordinate of the vertex is at the point 2, 9. So now let's visualize. A was a negative 1. So because A is negative, that means we have a downward facing parabola. So that vertex where the parabola changes direction from rising to falling is a high point. That is a maximum. That's the highest the graph goes. Now domain, we know we're going to go forever to the left, forever to the right, so negative infinity to positive infinity. The range is going to go as low as forever because it's going down, so negative infinity, and it's going to go as high as that vertex. Well, our vertex has a y-coordinate of 9, which means it's going to go as high as 9. And we're going to go ahead and do a strong bracket because we know for a fact it was 9. So understanding what the vertex is on the parabola helps us answer other questions. When you're done with that, let's move on to the next one. Let's see how quickly we can move through this now that we've seen it. The vertex can be found with x equals negative b over 2a. Did you follow that a is a negative 1, b is a negative 2, and c is an 8? So a negative negative 2 becomes a positive 2. 2 times negative 1 is negative 2, which simplifies to negative 1. So the vertex occurs when x is negative 1. Now we need to find our y-coordinate. So we're going to do that negative 1 times x squared minus 2 times x plus 8. So negative 1 squared, negative times negative is a positive 1, but that's times this outside negative 1. So that's negative 1. Negative 2 times negative 1 is positive 2 plus 8. So negative 1 plus 2 is 1 plus 8 is 9. So the vertex occurs at the point negative 1, 9. Is that a minimum or a maximum? Are you visualizing? Since A is a negative 1, it is a downward facing or sad parabola. The vertex is a maximum. It's a high point. The domain, left to right, it's going forever to the left and forever to the right. Now the range, it goes as low as forever, so negative infinity, and it goes as high as the y-coordinate of the vertex, positive 9. How did that feel? Were you able to keep up at that pace, or do you want to pause and rewind and watch it? Make sure you're okay with being able to find the vertex and understand how that affects the rest of the graph. When you feel comfortable with that, go ahead and move on to the next slide. Here, you have been given the graph, and I would like you to identify the vertex, the domain, and range. Now, the vertex is a high point, and it is located at negative 1, 2, 3, 4. And as far as how high it goes, it is at positive 7. Is that a minimum or a maximum? That is the highest it goes before it changes direction, so it's a maximum. The domain is forever to the left, forever to the right. The range, it goes as low as forever and as high as 7. How did that feel? Were you able to keep up with the pace as far as understanding what we're doing when the graph is drawn? If not, that's okay. Pause it, rewind it, and just watch it again. When the vertex is in the graph already drawn for us, it makes it a little bit easier to see. The vertex is our high point right here at negative 4, 7. Now, here's the real reason we're spending this time on this section. Let's see what a vertex has to do in real life. So for those of you who keep asking when are we ever going to work with quadratics in real life, here is an example. A softball player hits a fly ball in the air that can be closely modeled by this function. H of t, which is the same as y equals, negative 16t squared plus 48t plus 4. T represents the time in seconds. H represents the height of the softball. The question says, at what time is the ball going to reach its maximum height? Now think for a moment. When the ball is thrown by the pitcher, we should be able to visualize that it goes up and then it eventually does come down. So if I'm asking for the maximum height of the ball, what point on the parabola is that? Yes, I paused because I was hoping that you were thinking. The maximum height is the parabola, is the vertex of the parabola. And we know how to find the vertex. We know x is equal to negative b over 2a. So let's look at our equation. A is negative 16, b is 48, and c is 4. So we have a negative 48 over 2 times negative 16. That will give us negative 48 over negative 32. Now, don't panic if you see a fraction, negative 48 over negative 32. We know a negative over a negative is a positive, and in our calculators, if we type in 48 divided by 32, we get a nice number of 1.5 or 1.5. So if we are looking at the vertex, we know the x-coordinate is 1.5. What we need is the y-coordinate now, and then we'll have our vertex. Well, we're going to take a moment and sub in that number. We'll have negative 16 times 1.5 squared plus 48 times 1.5 plus 4. If you take a moment and put that into your calculator, if we do 1.5 squared, you will get 2.25. And then we're going to multiply that by negative 16. When we do that, this ends up as a nice whole number of negative 36. Now we have 48 times 1.5, and we get 72 plus 4. Well, negative 36 is plus 72 is 36, plus 4 is 40. So the y-coordinate of the vertex is 40. So now we need to understand what that answer actually means. So go back up front in the very beginning of the problem where it says right here where t represents the time in seconds and h represents the height. When we see h of t, that is really the y. So the y is our height and the x is our time. So that is something we need to make sure we are okay with understanding. When we have the equation y equals, that was h of t, which means we're finding the height. So the y is the height. So question A says, at what time is the ball going to reach its maximum height? Well, the time is at 1.5. And it does say up here it is in seconds. So it occurs at 1.5 seconds. Now the good news is for B, we've already answered it. What was the maximum height? Well, the height was right here, 40. It will reach 40 feet. And question C, what do the two values represent? Just to make sure we're clear, we said that the x-coordinate was our time and the y-coordinate was our height. So we will continue throughout this unit to look at examples of real-life situations, and we will continue in the future graphing them. But for today, I just wanted you to see the vertex, the numbers actually mean something. The 1.5 was the time it took for the ball to reach its maximum height. So in 1.5 seconds, it reaches its maximum height of 40 feet. Once you are good with that problem, you are done with your notes.